Hello there, everybody of YouTube. It's John Chaotic here, and yes, I'm doing something a little bit different today. And I did recently do like a Twitch stream on this. Oh, excuse me. Still a little full from Chinese that I had earlier today. So, all right. So, um, yeah. So, excuse me. As you know, everybody, or as you may come to know, that I am a huge nerd. Actually, I'm not a huge nerd, but I'm a pretty big nerd when it comes to paleontology. And ever since trying out like a couple paleontology streams, um, I thought why not I'd try to bring that back for YouTube and choose to make a YouTube video for today. And I figured I'd just read off of like a couple articles here, and then kind of just talk a little bit about the animal, or do a quick lookup of the animal. All right, so I have here four separate articles. From this one well, this recently came on my feed, so even though this was a few days ago, I recently it recently got my attention, or it came up on my feed. But um, but yeah, no. How about we just get right started on it? So, um, this one was honestly a little interesting. I remember hearing about this. Oh wait, this isn't the recent one. No, no, it's this one. Okay, my bad. But once in a million sea creature fossil preserves soft tissue for 450 million years. Sources from the University of Oklahoma, and here's a little summary of it. Scientists have identified exceptionally rare soft tissue preserved in a 450 million year old crinoid fossil, more than 200 million years older than the first dinosaurs. Its delicate tube feet offer a remarkable new window into how some of Earth's earliest reef animals lived, fed, and evolved. More than 450 million years ago, also these fossils look rather insane. And I mentioned it was a crinoid. I might have to look up what crinoids were real quick. I may have forgotten what that is specifically. Oh, okay, yeah, they're marine animals related to starfish and sea urchins that look like underwater flowers. Ah, I see. Okay, just wanted to refresh myself there, everybody. Alrighty, so more than 450 million years ago, long before dinosaurs appeared and before animals or plants have spread widely across dry land, crinoids were already thriving in some of the Earth's earliest coral reefs. These ancient relatives of starfish looked somewhat like flowers growing on stalks beneath the sea. Crinoid fossils give paleontologists important clues about how early animals evolved and how complex life developed. While fossils usually preserve only durable structures such as shells or skeletal plates, delicate tissues tend to disappear quickly after death, leaving major gaps in scientists' understanding of how these animals actually lived. A remarkably rare fossil studied by University of Oklahoma paleontologists is now helping fill in part of that missing picture. After an animal dies, soft tissues like skin, eyes, or internal organs are the first things to decay, said Dr. Lena Cole, OU paleontologist and assistant curator of Invertebrate Paleontology at the Sam Noble, Oklahoma Museum of Natural History. Most fossils are only made up of hard parts like bones, teeth, or shells. Soft tissues are only preserved when the environment acts almost like a natural refrigerator or vacuum sealer, conditions that are incredibly rare. Get a little itchy there. The fossil belongs to Dendrocrinus or Crinus simcoensis and preserves its tube feet, delicate structures that almost never survive fossilization. Cole and her colleagues describe the specimen in a new study. Only two known crinoid fossils have ever been found with preserved soft tissue. This specimen is also the oldest example discovered so far. Preservation like this is truly one in a million. Cole added, crinoid fossils number in the millions, and this is only the second time soft tissues have ever been found. Oldest crinoid soft tissue. The preserved tissues date back more than 450 million years, making them far older than the earliest dinosaurs. It's incredible to see these soft tissues survive more than 450 million years, said Dr. David White, another OU paleontologist and assistant curator of invertebrate paleontology at the Sam Noble, Oklahoma Museum of Natural History, who co-authored the study with Cole. For reference, these soft tissues are more than 200 million years older than the oldest dinosaur. For crinoids, tube feet play an important role in feeding, responding to water currents and occupying different ecological niches. Their size, spacing, and overall form can vary depending on the animal's surroundings and feeding method. In that sense, they can reveal information about lifestyle in much the same way that mammal teeth can reveal information about diet. Also, I've seen plenty of dorkly informations about that, but I'm trying not to get too distracted here. Since crinoid tube feet are used for feeding, you can think of them in a similar way to how we think about teeth in mammals, Ray explained. Differences in their structure tells us about what kinds of environments a species lived in and how it fed. When the researchers compared the fossils with crinoids living today, they found notable differences in anatomy. Comparisons with living crinoids show that the anatomy of this ancient species was very different, Cole added. This gives us new insight into how crinoids evolved and how their feeding strategies changed over hundreds of millions of years. New clues about ancient oceans. The fossil does more than expand the scientists' knowledge of crinoid anatomy. It can also help reconstruct the ecology of Paleozoic when crinoids, I could be saying it wrong. Hang on, you know what? How would you say it? I'm hoping. So I think I was saying it right the first time. Crinoids. Crinoids. Yeah. Okay, okay, never mind. I guess I was saying it right the first time, everybody. Alright. Fossilized remains of long extinct species can show features well outside the range of variation we see in living species, Wright said. By comparing ecological ways of life for extinct and modern species, we understand how patterns of adaptive evolution have changed through time and what factors shape the modern biosphere. Soft tissue is exceptionally uncommon in fossils of early echinoderms, the whole family that brings starfish and stuff. Larger animal group that includes crinoids and starfish. Because so little of it survives, every newly discovered specimen can greatly increase what researchers know about ancient ecosystems, feeding behavior, and evolutionary change. Excuse me. A rare fossil hidden in a museum collection. Many people picture many paleontological discoveries happening during expeditions in remote landscapes. Fieldwork does produce new fossils, but important discoveries can also emerge from specimens that have already spent years stored, cataloged, and protected in museums. New fossil discoveries ultimately come from fieldwork, but museum collections play a significant role in this kind of integrative research, Wright said. We don't always know the full significance of the specimens we collect. New technologies, ideas, or expertise often find surprising ways to utilize existing specimens to make new discoveries. The Dendrocrinus simcoensis fossil containing the preserved soft tissue had been housed for years at Montreal's Musée de Paleontologie et de l'Evolution. I might be saying that wrong. Small museum operates entirely with support from community donations. Its unusual scientific importance became apparent when crinoid specialists, Drs. Cole and Wright, examined the specimen closely during a research visit. This discovery highlights the importance of museum collections and the community support that keeps them alive, Cole said. Without the dedication of many people caring for these collections, this research would have never been possible, or would never have been possible. The invertebrate paleontology collections overseen by Drs. Cole and Wright at the Oklahoma Museum of Natural History contain more than 1,000, or no, not 1,000, more than 1,000,000 specimens, and additional fossils are added every year. Collections on that scale can hold discoveries that may not be recognized until years or even decades after the specimens were first collected. This is why we work to make our collections accessible to researchers around the world, Wright said. There are simply too many fossils to study over one person's career. There's more than a lifetime's worth of discoveries waiting to be found. And here's the story's source, materials provided by University of Oklahoma, and here is the original, here's citing the page, but yeah. So that's a little crazy about like the way that that this fossil looks right here. Let me see if there's any other like specific. So what was the name specifically? Oh crap! It's already 12 minutes. Oh wow. Huh. I didn't think it was actually going to take that long to read the first article. I'm going to be honest. I thought maybe I'd be reading that a little bit faster, but okay. I guess I'll just yeah. I guess I'll just save the other stuff for a little later. Alrighty. I guess I'll just read 2 articles and then I'll just call it quits after that. Alrighty. Oh yeah, that's right. I wanted to look up the name of. What was its name specifically? Okay, here we go. Copy that. Let's see if it shows us anything specifically. Well, that's definitely an interesting look. But I think this is probably the most we'll be getting with this. Wait. Oh. Another image. Alrighty, so let me just check to see. Oh, okay. All right. So this one's a bit of a shorter read, but this was also relatively rather interesting. Giant crocodilians dominated the food chain in Miocene South America, fossil evidence suggests, by University of Helsinki. Edited by Gabby Clark, reviewed by Robert Egan. And I know that specific animal specifically, Purosaurus. It was basically an ancient caiman, essentially. Um, and is kind of tied between this and Dinosuchus being like the biggest ancient crocodilian to have ever evolved. And also the family that brought the whole ancient crocodilians and shit was called is called Pseudosuchians. But all right, let's go ahead and get right in on this. So, South America was a frightening place during the Miocene. More than 10 million years ago, a vast lake covered much of the continent, home to giant turtles and crocodilians. A wide range of predators hunted on the lake's shores, including anacondas, saber-toothed mammals, flightless terror birds, and sebecids, terrestrial relatives of crocodilians. A recent study shows that crocodilians were, in fact, the most significant group of predators in this habitat. There was so much prey available that mammalian predators couldn't have eaten it all, says Oscar Wilson, a postdoctoral researcher at the University of Helsinki. A new study shows that crocodilians in particular were the region's most important predators, especially when it came to hunting large prey. The study was published in Journal of Vertebrate Paleontology. Bite traces reveal the predator. A great variety of herbivores lived on the lake's shores, giant ground sloths, glyptodonts, relatives of armadillos, and several groups of ungulates and astrapotheres, lightning beasts, and toxodontids. The ungulates of this era could weigh well over a ton. I'm assuming this is probably the jaws of one of these ungulates. Jaws of Xenastra wait Xenastrapotherium craglivici, and I might have just been butchering that, to be completely honest. But also, this looks. If this is the jaws for it, it's pretty crazy. But the predators were giants too. The largest predator of the time was a 7-meter long, 23 foot long, 1,800 kilogram, 4,000 pound crocodilian Porosaurus navensis, a relative of modern caimans. Like I said, at the top of the food chain, it may even have influenced the size of herbivore populations, the new study suggests. The research is based on an analysis of fossils held in museum collections. Bite and tooth marks left by predators on herbivore fossils are the only direct evidence of interactions between species. The fossils examined were between 10.5 million and 16 million years old. The frequency of marks likely made Porosaurus suggest that it was an important predator in these tropical ecosystems, Wilson comments. But also, yes, I do know Porosaurus a little bit because I remember watching a video from a YouTuber by the name of DinoFacts, I believe, where he did a whole video, like a whole 2+ hour video about the whole evolution of ancient crocodilians, I believe, from the very start of it to where we're at right now. But yeah, folks. Oh, wow, it is almost 20 minutes in. Okay. Alrighty, folks. So, like I said, I didn't want to. I didn't want to try to make this too long or anything. Not like my retro series videos, which I believe next week I am going to try and remake or not trying to remake, try to get back into recording another episode of of my retro series. But I'm hoping you guys enjoyed this little segment that I made here, or this little segment that I did with a couple paleontology articles. Again, I think it was because this one was actually a little longer in comparison to this one, but But yeah, no, I just felt like I wanted to at least do something that was kind of paleontology related, and I figured I just excuse me. I figured I would just go ahead and just read a couple articles. And before anyone says anything, I am by no means an expert, and I did not fully go to school yet for paleontology. But I would very much like to try that out, or maybe try that route out, and see where it goes from there. But at any rate, folks, thank you so much for tuning in. I know it's kind of like a little late for me recording this, but by the time this video gets released, it'll probably be about maybe like 12 o'clock tomorrow. So I'm going to set this video up as a premiere. And also, I do have a Discord link, which I will put in the description. If anybody wishes to come check out my Discord server, feel free to join in if you wish. With that being said, thank everybody so much for tuning in to this little video. It's gonna be John Chaotic signing out, and always remember, guys, trilobites. Have a good night, guys.